Wait, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Launch.
Right, the history of propulsion. It started way back in 400 BC when someone named Agitash first discovered the use of steam in propulsion. He first used steam escaping from a nozzle in order to move a model bird suspended on wires. It wasn't a discovery, more of a fun toy. It wasn't until about 100 BC when Hero of Alexandria made a device now called an
Eolipile.
The device was a suspended sphere with nozzles tangent to the circumference, which all was put over a boiling pot of steam. They managed to create propulsion by pumping steam into the sphere using pressure and then evaporating the water quickly to form propulsions in the nozzles, causing it to rotate around the axis. This was the first documented experience involving propulsion, an important factor when it comes to rocket design. The next example of propulsion came about in 100 AD when a Chinese started to experiment with propulsion by putting loads of gunpowder into bamboo tubes and lit it. These would sort of be called fireworks today. This type of propulsion is the type of propulsion we use today. It is called chemical propulsion. In the early first millennia, rocket propulsion was used in tons of different things, like weapons, cannons, all the way to torpedoes. It wasn't until the 17th century when a scientist named Isaac Newton coined the three laws of physics that allow propulsion to work. Although all the concepts and physics behind rockets were already in play, it wasn't until the early 20th century when people started using propellants in order to create some kind of motion, also called modern rocketry. An American scientist named Robert H. Goddard made experiments with model rockets and different types of propellants. Most of his early experiments involved solid fuel, making it impossible to vector or shut down the reaction. He was convinced that liquid-fueled rockets would be a better propellant because they could be vectored, but he also knew that they would be incredibly complicated to build, not to mention it would be very expensive in his time to create. But the cost of the model didn't sway him from attempting to create what would be the first modern rocket. Robert Goddard finally managed to create and successfully launch a liquid-powered rocket on March 16th, 1962. The experimental rocket flew 12.5 meters into the air and landed 56 meters away from the original launch point. By today's standards, this is quite unimpressive, but at the time it was a revolution in rocketry since no one before him had managed to get liquid fuel or vectoring to work inside a rocket chamber. He continued to experiment with this design and started adding things like gyroscopes, flight control, and payload spaces, which at this day are pretty common things to have in aircrafts and spacecrafts. Germany was inspired by Goddard's work and started creating missiles using the design of his engine. The rocket that they made was labeled the V-2 rocket. It could create big amounts of thrust by burning a propellant made out of liquid oxygen and alcohol, though very minimal compared to some rocket engines now. The revolution in using propulsion for missiles and long-range bombs gave way to the creating of some rockets that would eventually send humans into space. Space race, which created a competition now known as the space race between the US and the Soviet Union. On October 4th, 1957, the Soviet Union shocked the world when they first sent up the first artificial satellite up into geosynchronous orbit around the Earth. This satellite was called Sputnik 1. The USA quickly followed up with sending people to the moon using a rocket named the Saturn V in 1961. The rockets that were used to power both of these ships was quite similar to the one that Goddard had created. The propellant used to move these giant spacecraft has changed, but the system used to throttle and vector the point of thrust have stayed similar and have only gotten more compact. This new technology was incredibly efficient, but lacked thrust. These engines were called ion engines, and are currently the most efficient way to travel in space. Compared to the Saturn V, the thrust ratio is 34,000 to 0.0025 kilonewtons. But the comparison of efficiency is a different story. Compared to the Saturn V again, the ISP is 304 seconds to 4,190 seconds. The principles are the same as chemical rockets, as in the propellant is shot out the back of the ship, but in the case of ion engines, the propellant is the inert gas that is ionized through electricity and then shot out the back of the ship. This accelerates the gas and makes the ship able to let a very minimal amount of resources while still being able to produce a small amount of thrust. The fuel that it can use is specific to inert gases, xenon and argon being the two most common used propellants, but some engines can use other gases, which include helium, neon, krypton, and radon. The upper stages in spacecrafts today commonly use ions propulsion since it cannot get a probe out of the atmosphere, but it can get it going once outside the SOI of Earth. Things will change about rocketry, though, as different types of propulsions are being created at this day. New technology is already under development, like the electrostatic and electrothermal engines. They just use electricity to generate thrust. No propellant needed, only electricity. Engines aren't the only one thing that are being changed. The launch systems on rockets has changed a lot. Stronger laser-propelled launch systems are being developed. They work by using lots of lasers that will push orbiting objects overhead, which in turn can raise their orbit without the craft having to use any fuel. New ion engine types are being created as well, like the VAS-IMR engine, which is a more efficient and brushless engine that is predicted to be able to get astronauts to Mars in 40 days. Even in the distant future, we might have the incredibly efficient and also fantastical engine that is the warp drive, based on the one from Star Trek. Thanks to astronomers and aerospace engineers like Carl Sagan, Wernher von Braun, and people who first invented and discovered the principles to modern rocketry, Robert Goddard, Galileo Galilei, and Isaac Newton, we are now able to reach massive distances and discover the unseen, which mankind has only dreamed about making it to.